Hello everyone, welcome back. I am Dr. Sonal Jain from Department of Anthropology, University of Delhi. In this series of forensic science lectures, we have discussed various tools and techniques in forensic investigations, and we will continue to discuss different tools and techniques used in various divisions of forensic science for analyzing various evidences. So, whenever any evidence which is collected from scene of crime, we have to match it with a similar evidence. For that, we have certain class characteristics as well as certain individual characteristics. For example, if we talk about the evidences in the ballistics and explosives divisions, there are the evidences which can be commonly encountered or which can be commonly sent to the ballistics divisions are the various bullets, the projectiles, the cartridge cases, or the evidence or the murder weapon which is found at the scene of crime. So, to match the particular evidence which is collected from scene of crime, it should be a bullet should be matched to a bullet, a cartridge case should be matched to a cartridge case. The evidence which is collected from scene of crime is matched to the suspected bullet or the suspected cartridge case. The major instrument which is being used in the field of forensic ballistics is a comparison microscope. A comparison microscope is a device which is used to analyze side-by-side specimens. It contains two microscopes which are linked by an optical bridge and which outcomes in a divided view window, enabling two separate objects which can be viewed simultaneously. A comparison microscope is essentially two microscopes linked to an optical bridge that permits the observer to detect two objects concurrently with the same grade of magnification. This instrument can have a monocular or binocular eyepiece. That means either one can view with a single eye or with both the eyes. Two specimens are directly put together under the comparison microscope. The first specimen which is collected from the crime scene and the second specimen which is the suspected specimen. So, let us take an example of a bullet. There was a bullet which was being found at the scene of crime in the victim's body. After the autopsy, the forensic pathologist will collect the bullet and that bullet will go to the forensic ballistics division for analysis. Now, the bullet or the projectile which is being collected from the crime scene has to be matched with the bullet. This suspected bullet, now from where this match will come from where we will get the suspected bullet. So, the forensic scientists have to look for certain crime weapon and for the suspect bullet to be matched with the bullet at the crime scene, it should be being fired from the same weapon. So, as I was talking about the class characteristics and the individual characteristics, in the class characteristic, suppose the murder weapon is a 9 mm pistol. So, the projectile will have certain dimensions and the suspected bullet which is there, we can say yes, this particular projectile which is found from the victim's body is from a 9 mm weapon. So, that could be the suspected weapon. If the suspected weapon matches the bullet which is found at the crime scene, then that particular weapon comes under the suspected category. If the bullet, the projectile which is found in the victim's body and the weapon is different, then that weapon will not come under the suspected category. So, first of all, we have to see that whether that particular projectile or that particular bullet can be fired from the suspected weapon. After knowing that this could be the suspected weapon, there are certain rounds of fire which is being fired from the suspected weapon in the forensic ballistics division. The suspected weapon can be used for test firing various bullets. There is a proper cotton area where they fire the test bullets, and after that those suspected bullets which are being fired from suspected firearms are being matched with the bullets which are found at the crime scene. So, the bullets, the projectile which we have, or if we talk about the ammunition which is present in the weapon, the ammunition comprises of two parts. One is the cartridge case and one is the projectile above it, which we usually call the bullet. The projectile will go and can be found if it hits the target. The projectile can be found in the victim's body, and if it misses the target, then it can be found in nearby area. But the empty cartridge cases from the weapon are found near the area from where the projectile is being fired. So, those empty cartridge cases will be matched with the suspected cartridge cases which are being fired from the suspected firearm. So, the class characteristic would be that a 9mm bullet have certain dimensions and different rifle bullets have different dimensions. Shotgun projectiles have different dimensions. But if we talk about that, whether this particular weapon has been used for the killing of that particular victim, then we have to match that suspected firearm, firing from the suspected firearm, and we have to look for certain marks on the cartridge cases or the bullets or projectiles. Those are known as individual characteristics. For example, the firing pin mark present on the cartridge case, or there could be certain rifling marks on the projectile or bullets. We keep one sample on the left hand side of the comparison microscope and second suspected sample on the right hand side. As you can see in the figure that this is a cartridge case. In this left hand side and right hand side, we can see the screen together and the marks matches. So that means this particular weapon has been used for firing this particular cartridge case or bullet. This is an individual characteristic. The individual characteristic is the match which cannot be fired from any other firearm, and it is a confirmation that this is the only weapon used to fire this particular projectile. The comparison microscope has a TV screen attached to it, and the forensic ballistic expert put the left and right evidence together, and they can see the two images together. These two images together of the bullet or the cartridge case is known as juxtaposed image. That means two evidences can be seen together, and in the cases of bullet examination, cartridge case examination or tool marks examination, we mostly use the juxtaposed because we have to see that both matches, bullet matches, marks matches with each other in the cases of bullet, in the cases of cartridge case, in the cases of tool marks. Different cartridge cases have different class characteristics. They may have two rims on the back, they may have one rim on the back, and they are marked differently. These are the class characteristics. For example, if a cartridge case belongs to a rifle, it might be written AK-47, 9mm, 18mm, 12.5mm, depending on what kind of firearm through which it can be fired. So, the firearms which are manufactured properly in a factory, they have designated projectiles which can only be fired from those firearms. But there are certain firearms which are not manufactured with all the safety features in the factory, and they are known as country-made firearms. Country-made firearms do not have their proper projectiles, bullets or the cartridge cases, and thus different bullets or projectiles which are made for the properly manufactured firearms, they use their cartridges for firing, which might result in explosion sometimes because they are not properly fitted in the country-made weapons. Such country-made weapons are difficult to analyze because they don't have particular specifications and they are made by local people in different villages or cities. Another important evidence which can be found at the crime scene where any firearm has been used is gunshot residue. Gunshot residue is basically the combination of the powder which is filled between the cartridge cases and the projectile, and when it ignites, it raises to a very high temperature and give velocity to the projectile to hit the target. Now GSR analysis can be done. Basically GSR can be found at two places. It might be deposited on victim clothing or target that follows the path of the bullet, or GSR is deposited on the shooter's hand primarily from the primer. So if there is a suspect and he has used a firearm to kill a victim, then there is a probability that the GSR will be found on the hand of that particular suspect, in case if he hasn't washed his hands. GSR testing of hands is required. Whenever we have a suspect, then first of all we should take swab from the shooter's hand and we can examine this GSR under scanning electron microscopy. There are certain components of GSR which is lead, antimony, barium, particles. Various studies have been conducted and they suggest that the GSR residue resides on the hand of the persons for approximately 6 hours. So a suspect hands, the sample should be taken within 6 hours for testing of GSR. As we know, the components of GSR are lead, antimony and barium. There are certain chemical tests which we can apply when we take the wash from the suspect hands. It could be the modified grease test or the sodium rhodizonate test. In modified grease test, we specifically take burned and unburned gunpowder particles, and for nitrates it can be used, and sodium rhodizonate test is for the lead. The nitrates or the burnt or unburnt particles can be found at a distance, but the lead is usually found closer than the arm's length. So that means the lead test can only be applied to an arm's distance and can also be applied to the wash which has been collected from the suspect's hands. Sometimes there could be the negative results for the GSR test because suspect might have washed their hands, or shooter may have been wearing gloves, or there is no lead in the ammunition. In most of the cases of rifle and shotgun, there may not be any deposit of GSR on the hands. So whenever a firearm is being fired, then the web area, as you can see in the picture, there we can usually find the deposits of GSR. This web area, you can see the marked web area. This marked web area is usually the place from where the swabs are being taken, or the suspected person is asked to wash his hand in the solution, and then this solution is being tested for the presence of GSR and various chemicals which are there. In the cases of suicide also, if GSR is present on the hand of a suicide victim, it proves that he was holding the weapon when it was fired. So that is one important case where we can keep in mind for the GSR analysis to rule out whether this is a case of suicide or not. The chemical test of GSR is one analysis. Another important technique which is used for the GSR analysis is neutron activation analysis. The sample comprising of certain uncommon earth elements, they became radioactive after exposure to a source of neutrons. They rapidly predict the probable of engaging nuclear reactions on samples trailed by the capacity of the induced radioactivity to facilitate both qualitative and quantitative identification of many elements. So, neutron activation analysis can also be used for the GSR identification. We can get the peaks of various calcium, barium, and we can confirm that the element or the chemical powder which is being analyzed or the hand wash which is being analyzed has the traces of these particular elements, confirming that the residue was present on the suspect hand or the victim hand or on the clothing of the victim or the clothing of the suspect, confirming that he or she has fired any firearm. So, as we go for the making of a database in various cases, in forensic ballistics also we have one integrated ballistics identification system which is also known as IBIS. There are certain cases where we cannot procure the suspected firearm. A suspect has killed a victim and he has hid the firearm at some place, or that firearm has not been procured by the forensic scientist or by the police. In such cases, the images which are being taken from the samples, from the bullets, from the cartridge cases for the crime scenes, they are properly we make a database of such images, and they are stored and they are kept for comparison, that in future, in certain period of time, we might get handover to that particular firearm, and then we can match those images. So, to make the database of those particular images, we have this integrated ballistics identification system known as IBIS. The system is basically a screening tool that facilitates the laboratory to categorize local, national and international relationships that may exist among firearm cases surrendered for inspection. So, the firearm might be procured internationally from different countries. So, this IBIS system is an international network where on this platform these images are being circulated among different countries. From side to side, the application of computers and an improved microscope, an operator can compare previously recorded images to new evidence received. Imagings of projectiles and cartridge cases are digitally taken and then further they are uploaded for comparison and could be kept even in the cases where the cases are cold and we have nothing for comparison, and they could be compared in the future whenever we will procure the firearm. As we have IBIS, Integrated Ballistics Identification System, we have another system, National Integrated Ballistic Information Network. They produce database files from bullets and cartridge casings retrieved from crime scenes or test fires from various retrieved firearms. Whenever we have certain any comparison images for any comparison, we keep the digital images in the NIBIM system or the IBIS system. Another important work of forensic ballistic experts is to identify the range, that from what range the suspect has fired. As you can see the image, there could be the contact, the close range, the intermediate or the distance range. Depending upon from which distance the firearm is being fired, the wound will appear different either on the body of victim or on the clothing of victim. If it is a contact range, contact shot, maybe directly to the body of the victim, then the entry wound is pretty small because the firearm is in the touch of the victim's body. A nearby contact shot within a very close range will have unburned particles. An intermediate and distant range will have unburned particle in a larger area. And if the firearm is very far off, then the entry wound is very small. Thus, looking at the size of the entry wound either on the victim's body or on the victim's clothing, we can identify that from which distance the suspect or the criminal has fired the firearm over the victim. After confirming the range of firing, we can determine the distance, and we can clearly say that the range of firing can be determined. Another important evidences which are found at the crime scene and which are very important for the personal identification are the fingerprints. Like we have IBIS and NIBIN for the ballistics division, similarly in fingerprints division we have AFIS, that is Automated Fingerprint Identification System. This is a biometric system which is used in law enforcement, where group of prints improved in the crime scene were linked against the database of recognized and unidentified prints. That means if we have prints of criminals, they are being stored in the database, and whenever we find the fingerprints at the crime scene, we collect them, and then we can match those fingerprints to the database to identify whether this particular crime has been committed by a repeated offender and if his fingerprints are already in the system. AFIS is used by forensic scientists for criminal identification. Since fingerprints are the most often recorded physical evidence, constructing the system of investigating such prints really contribute the maximum toward greater success in identifying criminal offenders using this physical evidence, because the fingerprints are the evidence which are not same of any person. DNA can be same for the twins, but fingerprints are not same for any person. The automated fingerprint identification system enables computers to make rapid and accurate comparisons between fingerprints and the vast number of fingerprints in police records. So, if we have a print from the crime scene, then that print can be matched to the AFIS database, or we can upload prints from the suspects. Here also we have the class characteristics and the individual characteristics. For the class characteristics, we have arch, dented arch, right loop, left loop, double loop, right pocket loop, left pocket loop, whirl, or the mixed loops, where we have the mix of all the fingerprints there. For the class characteristics, we can say, okay, that could also be used that the fingerprints which are found at the crime scene, the index finger has a dented arch, but the suspect does not have a dented arch on the index finger. So it could be ruled out. But if there are 3 suspects and they all have dented arches on their left index finger, and the pattern which is taken from the crime scene is also showing that the left hand index finger has dented arch, then we have to go for various individual characteristics. We have to look in the fingerprint for the ridge ending, spur, crossover, bifurcation, etc. These are certain examples of the individual characteristics where we have island, fog, bridge, delta, core. We look for these individual characteristics. Different countries have different points of comparison for analysis. 7 to 12 points are needed for a perfect match in the fingerprints. So, whenever we encounter any evidence at the crime scene, firstly we should go for the class characteristic matching. If it eliminates number of suspects, then we go for the individual characteristic matching, and the individual characteristic matching will give us a concrete results in the cases of various physical evidences and can help us in identifying that who has committed that particular crime. Thank you.